Good morning, I'm Oliver, and today we're diving into two major AI stories from June 14th that might seem unrelated at first, but actually tell a fascinating story about where this industry is heading. First up, OpenAI just filed for its IPO with $1 trillion valuation, making all the headlines. But Jane, the real story here isn't about that massive number, is it?
Not at all, Oliver. Everyone's fixated on the $1 trillion, but what's really happening is a fundamental shift in where the value actually lies in AI. It's not about who has the smartest model anymore, it's about who controls what they're calling the harness. Think of it this way: raw intelligence is becoming a commodity, but the infrastructure that turns that intelligence into actual work, that's where the real battle is.
And that ties directly into our second story, a breakthrough called OpenSkill that lets AI agents essentially teach themselves new skills without human supervision. They're learning from documentation, code repositories, even web resources, and building their own practice environments. What's striking is how this could completely reshape who wins that infrastructure battle you mentioned.
Exactly. We're looking at two sides of the same coin here. On one hand, you have OpenAI trying to build the harness that companies will depend on. On the other, you have technology like OpenSkill that could let companies build their own autonomous AI capabilities. The question becomes, in a world where AI agents can evolve themselves, who actually needs to own the underlying infrastructure? Let's break down what's really at stake. So let's talk about what everyone's missing with this OpenAI IPO filing. Yes, $1 trillion sounds massive, but here's the thing. That valuation is based on an old way of thinking about AI value. The market is still obsessing over who has the best model, the highest benchmark scores, the most parameters. But the real strategic battle is happening at a completely different layer. OpenAI and Anthropic know this. Their IPO value isn't going to come from having the smartest raw intelligence. It's going to come from controlling what they call the harness.
Okay, break that down for me. When you say harnesses versus raw intelligence, what exactly are we talking about here? Because most people think of these companies as model companies, right? They train the big language models, they serve the API endpoints.
Right, and that's exactly the misconception. Think of it this way: a token is just raw intelligence. It's the model spitting out text or reasoning through a problem. But a harness is everything that turns that intelligence into actual work. We're talking about context management, tool integration, permission systems, memory, evaluations, routing between different models, workflow orchestration, all the messy infrastructure that makes AI actually useful in a business setting.
That's a fascinating distinction. So you're saying OpenAI's real bet isn't that GPT will always be the smartest model, but that they can build the best infrastructure layer around intelligence. What does that mean for someone like Google or Microsoft, who are also in this race?
Exactly. And here's where it gets really interesting from a competitive standpoint. If tokens become commoditized, and they will, because models are getting cheaper and more abundant, then whoever owns the harness captures the value. OpenAI is essentially betting they can become the operating system for AI work, not just the provider of smart responses. They want to own the routing logic that decides which model handles which task, the evaluation systems that check quality, the workflow definitions that turn intelligence into business processes.
But that raises a critical question about competitive moats, doesn't it? If the harness is where the value is, what stops every major tech company from building their own? Google has enterprise relationships, Microsoft has Office integration, Amazon has AWS infrastructure. Are we looking at a winner-take-all market, or is this going to fragment?
That's the $1 trillion question, literally. And it gets to the heart of why this IPO filing is so strategic. OpenAI needs to prove they can build harnesses faster than companies can build their own, and embed so deeply into workflows that switching becomes painful. Because once a company's entire workflow wraps around your harness, even if better models come along, the switching costs become enormous. It's classic platform strategy, but applied to intelligence infrastructure.
All right, Jane, I want to dig much deeper into this harness concept because I think our listeners need to understand what we're actually talking about here. You mentioned context management, tools, permissions, memory, evaluations, routing, workflow orchestration. That's a lot of moving pieces. Let's break this down component by component. Start with context management. What does that actually look like in practice?
Great question. Context management is basically the system's ability to understand and maintain what's relevant for each specific task or conversation. Think about it. When you're working with AI in a business setting, the model needs to know what company policies apply here, what previous decisions were made, what's the current project status. A good harness maintains all that context and feeds it to the model appropriately. It's not just about having a smart model, it's about having a smart model that knows what it's working with.
That makes sense, but that raises a question about scale and complexity. How do you maintain context across thousands of employees, multiple projects, constantly changing business rules? And then you mentioned tool integration. I assume that's about connecting the AI to actual business systems?
Exactly. Tool integration is where the rubber meets the road. Your AI might be brilliant at analyzing data, but if it can't actually access your CRM, pull from your database, update your project management system, or send that email, it's just an expensive chatbot. The harness is what connects the intelligence to your actual workflow. And you're right about the complexity problem. That's why this is so valuable. Building robust context management that scales across an entire enterprise, that's incredibly hard. Most companies would rather rent that capability than build it.
Okay, but what about permissions and security? Because if you're giving AI access to business systems, you need granular control over what it can and can't do, right? This seems like it could get complicated very quickly.
Absolutely. And that's another massive piece of the harness puzzle. A proper permission system doesn't just control what the AI can access, it understands roles, approval workflows, compliance requirements, audit trails. Can this AI approve purchases up to $10,000? Can it access customer data from the European Union? Should it route certain decisions through a human supervisor? All of that logic has to be built, maintained, and constantly updated as regulations change. It's enterprise software complexity applied to intelligence.
And then there's the evaluation piece. How do you even know if the AI is doing good work? Traditional software either works or it doesn't, but AI output can be subtle, contextual, partially right. How does a harness handle quality control?
That's probably the trickiest component, honestly. Evaluation systems in a good harness are doing constant quality checks. Is this output accurate? Is it following company guidelines? Is it appropriate for this context? Some of that can be automated with other AI models checking the work. Some requires human review workflows. Some need statistical monitoring over time. And it all has to happen fast enough to be useful. Building reliable evals that actually correlate with business value, that's an art as much as a science.
Now I'm starting to see why this is so strategic. But let's talk about routing, because presumably you're not using the same model for every task. How does the harness decide what intelligence to apply where?
Exactly. Smart routing is like having a brilliant dispatcher for your intelligence resources. Maybe you use a fast, cheap model for simple classification tasks, a more expensive model for complex reasoning, a specialized model for code generation, and a different one entirely for image analysis. The harness needs to understand the task, the performance requirements, the cost constraints, and route accordingly. And it needs to do this seamlessly. The user just asks for something to get done. They don't care which model actually handles it.
But here's what I'm really curious about. Why does this matter more than just having the best raw model? I mean, if OpenAI builds GPT that's 10 times smarter than everything else, Doesn't that trump all this infrastructure complexity?
This is the key insight that I think the market is still missing. Raw intelligence is rapidly becoming abundant and cheap. The article mentions that API prices have 70 to 80% margins built in. The actual cost to serve is much lower. Multiple companies are building capable models, but even if you have the smartest model in the world, if it can't integrate with my workflow, access my context, follow my permissions, route efficiently, and prove it's doing quality work, it's useless to me as a business.
So you're saying the competitive advantage shifts from who has the smartest AI to who has the most integrated, reliable, scalable infrastructure for deploying that intelligence. That's a fundamentally different kind of technology company, isn't it?
Exactly. It's the difference between being a research lab that builds impressive demos and being a platform that runs mission-critical business operations. Think about it. AWS didn't win because they had the best servers. They won because they built the best infrastructure for deploying and managing compute resources. OpenAI is betting they can be the AWS of intelligence. And just like with cloud computing, once your entire operation is running on their infrastructure, switching becomes incredibly painful, even if someone else builds a better underlying technology.
That's a fascinating parallel. And it explains why this IPO valuation might actually be justified. They're not just selling access to a smart model, they're positioning to become essential infrastructure. But that also suggests this market could support multiple winners, right? Different harnesses for different use cases?
Potentially, though there are some powerful network effects and integration advantages that could lead to consolidation. The harness that best understands your workflow becomes more valuable over time. It learns your patterns, optimizes your processes, builds up institutional memory. That's incredibly sticky. But you're right that we might see specialization. Maybe one harness dominates financial services while another owns manufacturing operations. The key is that whoever owns the harness captures the value, regardless of whose raw intelligence is flowing through it. Now, here's where the economics get really interesting, Oliver. Everyone sees these $200 unlimited AI plans from companies like OpenAI and thinks they're either desperate or crazy. But when you understand the actual cost structure, it starts to make perfect strategic sense. The dirty secret of AI pricing is that current API prices have 70 to 80% margins built into them. The actual cost to serve these requests is dramatically lower than what companies are charging.
Wait, 70 to 80% margins? That seems almost too high to be sustainable. Are you saying that when I pay $1 for API credits, the actual compute cost might be 20 or 30 cents? How is that possible when everyone talks about how expensive these models are to run?
Exactly. The infrastructure costs are real. Training these models costs millions. Running the data centers requires massive investment. But the marginal cost of serving an additional request, much lower than the pricing suggests. Think about it like cloud computing in the early days. Amazon was charging premium prices for AWS because they could, not because they had to. The same thing is happening with AI APIs. Companies are pricing based on value captured, not cost incurred.
But that raises a critical question about competitive dynamics. If margins are that high, what stops competitors from undercutting on price? And more importantly, can these unlimited plans actually be profitable, or are they loss leaders designed to lock in customers while the companies figure out the harness strategy we were discussing?
That's the brilliant part of the strategy. These unlimited plans aren't irrational. They're calculated moves to accelerate harness adoption. Think about it. If I'm paying per token, I'm incentivized to use AI sparingly, carefully, only for high-value tasks. But if I'm paying a flat $200, suddenly, I'm experimenting everywhere, building AI into every workflow, getting my entire organization dependent on the platform. I'm essentially paying OpenAI to become essential to my business operations.
So it's about changing user behavior and increasing platform dependency, not just about the direct economics of that $200. But I have to ask, what happens when competition heats up and these margins compress? Can this pricing strategy survive in a more competitive market, or is this just a temporary advantage while the market is still developing?
That's the key question, and it ties directly back to the harness strategy. If OpenAI succeeds in becoming essential infrastructure, if companies build their entire AI workflows around OpenAI's harness, then they can maintain pricing power even as raw compute gets cheaper. It's like how AWS maintained premium pricing even as server costs plummeted, because the switching costs and integration complexity created real stickiness. The unlimited plans are essentially an investment in creating that stickiness before the competition catches up.
But that also suggests this is a race against time, doesn't it? OpenAI needs to establish that platform dominance before competitors can offer similar harness capabilities at lower prices. And if companies start building their own harnesses, or if something like the OpenSkill technology we're discussing later lets them develop autonomous AI capabilities, does this whole pricing strategy fall apart?
Absolutely. This is why the IPO timing is so critical. OpenAI needs capital to accelerate harness development and market penetration before the window closes. They're essentially betting that they can build enough platform stickiness in the next few years to justify these valuations. But you're right. If companies start successfully building their own AI infrastructure, or if autonomous agents reduce the need for managed platforms, then these economics look very different. It's a high-stakes game with a potentially massive payoff, but also significant execution risk.
But here's the strategic insight that I think changes everything about this harness battle, Jane. Everyone assumes the AI labs hold all the cards because they have the models and the infrastructure. But actually, companies have a massive, underappreciated advantage. They own the private context. Think about it. Every company has their own workflows, their own documents, their own approval processes, their own definitions of what constitutes a reliable source versus something that's just noise. That's incredibly valuable data that no AI lab can replicate or access from the outside.
That's a fascinating point, Oliver. You're saying that while OpenAI might have the smartest model, they don't actually know how my company operates day to day. They don't know that when our sales team says high priority, it actually means something different than when our engineering team uses the same phrase. They don't know our internal approval chains, our compliance quirks, our tribal knowledge about which processes actually work versus which ones exist on paper. All of that context is locked up inside the company.
Exactly. And this context isn't just nice to have information. It's absolutely critical for making AI useful in practice. Your AI might be brilliant at writing emails, but if it doesn't understand your company's communication style, your client relationships, your internal politics, it's going to produce output that's technically correct but practically useless. The company that figures out how to harness AI while keeping control of their proprietary context could actually flip this whole power dynamic on its head.
But the AI labs aren't just sitting back and accepting this disadvantage, Oliver. They're fighting back with what's called forward-deployed engineering. Essentially, they're embedding their engineers directly inside companies, not just as customer support, but as workflow archaeologists. These engineers spend months mapping how companies actually work, documenting the unwritten rules, the exception cases, the human judgment calls that happen 100 times a day. They're trying to extract that private context and build it into their harnesses.
That's a fascinating arms race. So you're describing a situation where AI labs are essentially doing organizational consulting, trying to reverse engineer decades of institutional knowledge and encode it into their platforms. But how scalable is that approach? I mean, every company thinks their workflows are unique, and often they're right. Can forward-deployed engineering really capture the nuances that make each organization special, or are they just getting the surface-level stuff?
That's the trillion-dollar question, literally. The companies that succeed with forward-deployed engineering are those that go deeper than just documenting the official process. They're mapping the shadow workflows, the Slack channels where real decisions get made, the informal networks that actually drive approvals, the tribal knowledge about which metrics matter versus which ones are just for show. But you're right about scale. This is incredibly labor-intensive. Each deployment requires months of embedded work, and if they get it wrong, the AI integration fails spectacularly. It's high touch, high value, but also high risk for the AI labs. This brings us to what I think is the most critical strategic decision every company needs to make right now, Oliver. It's a decision that most executives don't even realize they're making. The question is simple. Are you going to rent your AI capabilities, or are you going to own your harness? Because that choice is going to determine whether you end up controlling your AI destiny or becoming completely dependent on someone else's platform. And once you go down one path, switching becomes incredibly expensive.
Break that down for me, Jane. When you say owning the harness versus renting, what does that actually look like in practice? Because I imagine most companies right now are just plugging into OpenAI's API or Claude's interface and thinking that's their AI strategy. Are you saying that's fundamentally the wrong approach?
It's not wrong, but it's incredibly risky if you don't understand what you're giving up. When you rent the harness, you're essentially letting OpenAI or Anthropic control your routing logic. They decide which models handle which tasks. They control the evaluation systems that determine quality. They own the workflow definitions that turn your requests into actions. You get convenience and speed to market, but you also get locked into their way of doing things. Owning the harness means you build those capabilities internally. You control how intelligence gets routed. You define what good output looks like. You maintain the logic that connects AI to your business processes.
But that sounds incredibly complex and expensive to build in-house. I'm thinking about a mid-sized company, say a regional bank or a manufacturing firm. Do they really have the technical capability to build their own AI routing systems and evaluation frameworks? Or is this only realistic for tech giants like Google and Microsoft?
That's exactly the right question, and it gets to the heart of the strategic trade-off. A regional bank probably can't build GPT-4 level models, but they absolutely can build the routing logic that decides when to use a cheap model for simple classification versus an expensive model for complex analysis. They can define evaluation criteria that reflect their specific compliance requirements. They can control the context management that determines what customer data gets shared with which AI systems. The key insight is that you don't need to train models to own the harness. You need to own the business logic that governs how intelligence gets applied.
So you're saying there's a middle path here? Use someone else's raw intelligence but maintain control over how it gets deployed? But how do you prevent vendor lock-in in that scenario? If I build my workflow around OpenAI's API structure and then want to switch to Claude or some future provider, don't I end up rewriting everything anyway?
That's where smart harness design becomes crucial. If you own the harness, you're building abstraction layers that can work with multiple providers. Your routing logic says, send this type of request to the best available reasoning model. It doesn't hard code send to GPT-4. Your evaluation systems check output quality based on your business criteria, regardless of which model generated the response. Your workflow definitions focus on business outcomes, not API specifications. Done right, you can swap providers without changing your core business logic. Done wrong, and you're completely trapped.
But there's got to be a significant cost to building and maintaining that abstraction layer. And what about innovation? If OpenAI releases some breakthrough harness feature, companies that own their infrastructure might miss out or be slow to adopt. Are we looking at a classic build versus buy decision, or is there something fundamentally different about AI infrastructure that changes the calculus?
It is fundamentally different, Oliver, because the switching costs are so much higher than traditional enterprise software. If I decide my CRM isn't working and want to switch from Salesforce to HubSpot, it's painful but doable. but if my entire organization has built their workflows around OpenAI's harness, if our approval processes, our quality checks, our routing decisions, our context management all depend on their platform, switching becomes almost impossible. We're not just changing a tool, we're rewiring how work gets done across the entire company.
That's a sobering thought. But let me push back on something. You mentioned missing out on innovation if you build your own harness. In a field that's moving as fast as AI, isn't there a real risk that companies that go the build route end up with inferior capabilities? How do you balance control and flexibility against staying on the cutting edge?
That's the strategic tension, and honestly, there's no perfect answer. But here's what I think companies need to consider. The most important innovations might not be in the models themselves, but in understanding how to deploy intelligence effectively in your specific context. OpenAI might build amazing new capabilities, but they'll never understand your business as well as you do. The question is whether generic, powerful tools are more valuable than specialized, contextual ones. And remember, if you own the harness, you can still adopt new models as they become available. You're not locked out of innovation, you're just controlling how it gets integrated.
So, what's your take on how different types of companies should approach this decision? You mentioned a regional bank earlier. Are there certain industries or company sizes where the build approach makes more sense? And are there others where renting is clearly the better choice?
I think it comes down to three factors: how AI dependent your business model is, how differentiated your workflows are, and how much technical capability you can realistically build or acquire. A logistics company whose competitive advantage depends on AI optimized routing, they probably need to own their harness. A law firm that uses AI for document review but isn't fundamentally an AI business, renting might make sense. But here's the thing: every company needs to make this decision consciously. The worst outcome is sleepwalking into total platform dependence and then realizing you can't escape when you need to.
And that raises a timing question, doesn't it? We're still in the early days of enterprise AI adoption. Is there a window where companies can build their own harnesses before the platforms become too entrenched? Or conversely, is there a risk of building too early, before the standards and best practices are established?
That's the critical timing question. Build too early, and you might invest in the wrong abstractions or miss key innovations. Wait too long, and you might find yourself so dependent on external platforms that building becomes prohibitively expensive. My sense is that companies should start building the components they understand best: their evaluation criteria, their context management, their workflow definitions, while staying flexible on the pieces that are still evolving rapidly. The key is maintaining optionality. Don't let convenience today become dependence tomorrow.
Now, Jane, while we've been talking about this battle for AI infrastructure control, there's a second story from today that could completely change the game. It's called OpenSkill, and it represents a fundamentally different approach to AI development. Instead of companies or AI labs building these carefully curated training systems, we're looking at AI agents that can literally teach themselves new skills without any human supervision. They're learning directly from documentation, code repositories, web resources, essentially bootstrapping their own capabilities from scratch.
Wait, Oliver. That sounds almost too good to be true. When you say, without human supervision, how is that different from how current AI systems learn? I mean, GPT models are trained on massive datasets from the web, right? What makes OpenSkill's approach fundamentally different from just scaling up that kind of training?
That's exactly the right question, and the distinction is crucial. Current AI training is massive but passive. You feed models enormous datasets, they learn statistical patterns, but they can't actively seek out knowledge or build their own learning environments. OpenSkill agents are actively exploring. They'll read documentation, extract actionable knowledge, then build virtual practice environments to test and refine their understanding. It's like the difference between memorizing a textbook and actually conducting experiments to verify what you've learned.
Okay, but I'm still not clear on the mechanics here. You mentioned they build their own practice environments. What does that actually look like? And how do they know if they're learning the right things without human feedback? Traditional AI training relies on massive human annotation and careful curation of training data. Are you saying these agents can somehow evaluate their own progress?
Exactly! And that's perhaps the most impressive part. They're building their own verification systems. The agents create what the researchers call self-built verifiers that can assess whether their learned skills actually work. And these verifiers align with real-world outcomes even though they never had access to ground truth during development. So an agent might learn about database optimization from documentation, build a test environment to practice those skills, and develop its own evaluation criteria to measure success, all without human oversight.
That's fascinating, but it raises a question about reliability and trust. How do we know these self-taught agents are learning the right lessons? I mean, if an agent misinterprets documentation or develops flawed evaluation criteria, couldn't it confidently execute tasks incorrectly? Current AI training at least has human oversight at key points. This sounds like it could produce very capable but potentially unpredictable agents.
You're highlighting the key tension here, Jane. But what's remarkable about OpenSkill is that these agents are achieving what they call the highest automated pass rates across multiple benchmarks while maintaining this no supervision constraint. And here's what ties back to our harness discussion. These skills are completely model agnostic. An agent can develop a skill using one model, then transfer that capability to a completely different model without any adaptation. That could fundamentally change who needs to own AI infrastructure.
Now that's a connection I hadn't considered. If agents can teach themselves and transfer skills across different models seamlessly, does that reduce the importance of being locked into any particular platform? You could theoretically have agents that evolve their capabilities independently of whether you're using OpenAI, Claude, or some future model we haven't seen yet. That sounds like it could disrupt the entire harness strategy we've been discussing. All right, Oliver, let me walk you through how OpenSkill actually works, because the technical approach is genuinely groundbreaking. The system starts with what they call open-world bootstrapping. An agent literally begins with access to documentation, code repositories, maybe some web resources, and absolutely no curated training data or human examples. From there, it has to figure out what skills exist, how to learn them, and how to verify it's learning correctly. The first step is knowledge extraction. The agent reads through documentation and identifies actionable capabilities it could potentially develop.
So it's essentially doing its own curriculum design? But Jane, how does an agent even know what constitutes a skill worth learning? I mean, when I read documentation, I'm bringing years of context about what's useful versus what's just reference material. How does an agent bootstrap that kind of judgment without any prior examples of successful skill acquisition?
That's where the framework gets really clever. The agents aren't just randomly reading, they're looking for patterns that suggest actionable knowledge. Things like step-by-step procedures, code examples with clear inputs and outputs, documentation that describes transformations or problem-solving approaches. They're essentially mining for procedural knowledge that can be turned into executable skills. And here's the key part. Once they identify a potential skill, they don't just memorize it, they synthesize it into what they call transferable skill representations.
Okay, but synthesizing is one thing. How do they actually practice and refine these skills? You mentioned virtual practice environments. Are we talking about the agents creating their own sandbox testing scenarios? And if so, how do they ensure those environments actually reflect real-world conditions they'll encounter?
Exactly. This is where it gets fascinating. The agents build their own practice environments based on their understanding of the skill domain. So, if an agent is learning database optimization, it might create synthetic datasets, generate realistic query workloads, and build test scenarios that mirror the conditions described in the documentation. The environment isn't just a static test, it's dynamic, allowing the agent to experiment, fail, iterate, and refine its approach. It's like having a flight simulator, but the pilot also designed and built the simulator.
But that raises a critical question about validation, Jane. How does the agent know if its self-built practice environment is actually realistic? And even more importantly, how does it evaluate whether it's performing well in that environment? Traditional machine learning relies on ground truth labels, human feedback, or at least some external validation signal. What's the equivalent here?
This is the most impressive part of the whole system, Oliver. The agents develop what the researchers call self-built verifiers. Essentially, they're creating their own evaluation systems based on their understanding of what success should look like. And here's the remarkable thing. These self-built verifiers actually align with ground truth outcomes, even though they never had access to external validation during development. The agent might learn that database query optimization should reduce execution time and resource usage, then build verification logic that measures those metrics and correlates them with query complexity.
That's almost hard to believe. You're saying these agents can bootstrap not just skills, but also the ability to evaluate those skills accurately. How do we know the self-verification isn't just confirming the agent's biases? If an agent misunderstands what good performance looks like, couldn't it build a verifier that consistently validates poor performance as successful?
That's exactly the skepticism you'd expect, and it's why the research results are so compelling. The agents are achieving what they call the best automated pass rates across multiple established benchmarks. Benchmarks they didn't train on or optimize for. The self-built verifiers aren't just internal consistency checks, they're actually predictive of real-world performance. The key seems to be that when agents extract knowledge from diverse, high-quality sources and synthesize it properly, their understanding of success criteria tends to align with objective measures of performance.
All right, but let's talk about the model-agnostic aspect, because that could be the real game changer here. You're saying these agents can develop a skill using one underlying model, let's say Claude, and then transfer that exact skill to GPT or some other model without any adaptation? How is that technically possible when different models have different architectures, training, and capabilities?
This is where the abstraction layer becomes crucial, Oliver. The agents aren't learning model-specific tricks or exploiting particular architectural features. They're learning general problem-solving approaches, logical frameworks, and procedural knowledge that can be expressed through any sufficiently capable language model. Think of it like learning to drive. Once you understand the principles of steering, braking, and acceleration, you can apply those skills whether you're in a Honda or a BMW. The underlying mechanics are different, but the skill transfers because it operates at a higher level of abstraction.
But surely there have to be some limitations to that transferability. Different models have different strengths, weaknesses, context lengths, reasoning capabilities. If an agent develops a skill that relies heavily on long-form reasoning and then gets transferred to a model with limited context, doesn't the skill degrade? Or do the agents somehow adapt their approach based on the capabilities of their current model?
You're right that there are practical constraints, but the framework handles this more elegantly than you might expect. The agents learn skills at multiple levels of granularity and complexity. They might develop both a sophisticated approach that requires extensive reasoning and a simpler fallback method for more constrained environments. The skill representation includes not just the primary approach, but also information about when and how to adapt the method based on available capabilities. It's like having a recipe that includes both the full elaborate version and a quick simplified version, depending on what ingredients and tools you have available.
That adaptive capability is intriguing, but it also raises questions about skill composition and interaction. If an agent learns multiple skills through this bootstrapping process, how does it combine them effectively? And how does it handle situations where skills might conflict, or where the optimal approach requires integrating knowledge from multiple learned capabilities?
That's where the learning loop really shines, Oliver. The agents aren't just acquiring isolated skills, They're building what you might call a skill ecosystem. As they develop new capabilities, they're also learning how those skills relate to each other, when to combine them, and how to resolve conflicts between different approaches. The virtual practice environments become more sophisticated over time, presenting scenarios that require skill integration and forcing the agents to develop meta skills around skill selection and composition. It's like going from learning individual musical instruments to learning how to conduct an orchestra.
So we're looking at agents that can essentially evolve their own capability stack over time, learning not just individual skills, but also the orchestration layer that decides how to deploy those skills effectively. That sounds like it could make traditional approaches to AI training and deployment look obsolete. If agents can bootstrap this kind of comprehensive capability development, what does that mean for the entire infrastructure we've been discussing? Do companies still need these elaborate harnesses if their agents can essentially build their own?
Now you're getting to the strategic implications that could reshape everything, Oliver. If agents can truly self-evolve and transfer skills across models seamlessly, it potentially democratizes advanced AI capabilities in a way that breaks the platform lock-in strategies we discussed earlier. A company could theoretically deploy OpenSkill-style agents that continuously improve their own capabilities, adapt to new models as they become available, and reduce dependence on external AI platforms. But that also assumes these agents can scale reliably and maintain alignment with business objectives as they evolve. The technology is promising, but the organizational and control challenges might be even more complex than the current harness approach.
Now, Jane, I think we need to step back and look at how these two stories actually connect, because I'm starting to see a potential collision course that could reshape everything we've discussed. On one hand, you have OpenAI and other labs betting their trillion-dollar valuations on controlling the harness, becoming the essential infrastructure layer that companies depend on. On the other hand, you have OpenSkill, demonstrating that agents can bootstrap their own capabilities and transfer skills across any model. If companies can deploy self-evolving agents that continuously improve without platform dependence, does that completely undermine the harness strategy?
That's exactly the strategic tension I've been thinking about, Oliver. If OpenSkill-style agents can truly self-evolve and remain model-agnostic, it could flip the entire power dynamic. Instead of companies becoming dependent on OpenAI's harness, they could potentially deploy agents that build their own capabilities over time, adapt to whatever models are available, and reduce their platform lock-in risk. But here's what I think the AI labs are betting on. Even if agents can self-evolve, someone still needs to provide the underlying intelligence, the compute infrastructure, and the reliability guarantees that enterprise customers demand.
But that assumes the current model of centralized AI providers remains dominant. What if self-evolving agents accelerate the commoditization of intelligence even faster than we expected? If an agent can learn from documentation and web resources, continuously improve its own capabilities, and work with any underlying model, then the switching costs we talked about earlier, all that workflow integration and context management, become much less sticky. Companies could potentially treat AI providers like they treat cloud storage, important infrastructure, but easily replaceable.
That's a fascinating possibility, but I think there's a critical implementation challenge we're not fully considering. Self-evolving agents sound amazing in theory, but enterprise adoption requires reliability, predictability, and control. A regional bank might love the idea of agents that improve themselves, but they also need to ensure those agents don't evolve in ways that violate compliance requirements or make decisions outside approved parameters. The harness providers could actually benefit from this. They could offer managed environments for self-evolving agents, providing the governance and reliability layer that companies need.
So you're suggesting a hybrid model where the competitive advantage shifts again? Instead of controlling raw intelligence or even the basic harness infrastructure, the winners might be those who can provide governed environments for autonomous agent evolution? That's intriguing, but it also raises the stakes considerably. If agents are continuously learning and adapting, the complexity of ensuring they remain aligned with business objectives becomes exponentially harder. Who do you think is better positioned to solve that challenge? The AI labs with their technical expertise, or the companies with deep domain knowledge?
I think that's the trillion-dollar question that these two stories together are really asking. The AI labs have the technical capability to build sophisticated agent management systems, but companies have the contextual knowledge to define what good behavior actually looks like in their specific domain. My sense is we're heading toward a more complex ecosystem than either a pure harness rental model or a pure build-your-own agents model. The winners might be whoever can bridge that gap most effectively, providing the technical infrastructure for agent evolution while allowing companies to maintain control over the governance and alignment aspects.
And that suggests the competitive landscape becomes much more nuanced, doesn't it? Instead of a simple battle between AI labs trying to lock in companies versus companies trying to maintain independence, we could see different strategies succeeding in different contexts. Some companies might prefer fully managed agent evolution from trusted providers. Others might want to own their agent development infrastructure, and still others might try to build hybrid approaches. The timing question becomes critical. Companies that make these architectural decisions now could be locked into their chosen path for years to come. Jane, as we wrap up today's episode, I think we've uncovered something really fundamental here. These two stories together reveal that we're witnessing a complete shift in how AI competition actually works. It's no longer about who builds the smartest model, it's about who controls the infrastructure layer that makes intelligence useful. And with self-evolving agents like OpenSkill potentially changing the game entirely, we're looking at a much more complex strategic landscape than most companies realize.
Exactly, Oliver. And the critical takeaway for any business leader listening is this. The decision you make about owning versus renting your AI capabilities isn't just a technology choice, it's a strategic choice that could determine your competitive position for the next decade. Whether you build your own harness, rent from platforms like OpenAI, or deploy self-evolving agents, you need to make that decision consciously and understand the long-term implications. Because once you're locked into a particular approach, changing course becomes exponentially more expensive.
And that raises the question of timing, doesn't it? For investors and industry watchers, what should we be looking for in OpenAI's S1 filing to understand whether their trillion-dollar bet is actually going to pay off? What metrics will tell us whether they're successfully building that harness moat we've been discussing?
Great question. I'd watch for three key things. First, cost to serve trends and gross margins at scale. Are they actually achieving the economics that make unlimited plans sustainable? Second, the split between enterprise product revenue versus custom deployment revenue. That tells us whether they're winning with standardized harnesses or having to do expensive custom work for every client. And third, workflow integration depth. How embedded are they becoming in actual business processes versus just providing API access? Those metrics will tell us whether OpenAI is becoming essential infrastructure or just another AI provider. That's what will determine if this trillion-dollar valuation holds up in a world where intelligence is getting cheaper and agents are getting smarter.